Awesome. So I'm John Sherwood. I am a PhD student in environmental engineering, and I've used Tableau for like 7 years now, on and off. It's an awesome program, so we'll be talking about that today. The plan for today is to go through a quick presentation about what data visualization is, and we'll talk a little bit about the background of Tableau, and then we'll get into the workshop portion and work through it. So I developed this presentation when I was at Argonne National Lab, which is why I haven't changed it over to Clemson colors. I was trying to think of a good joke to put on the title, but all the good ones are gone. It's a great pun. It's so good. Argonne. This is an interactive workshop, so I would greatly appreciate all of your participation. You don't have to laugh at corny jokes, but I am curious what people use for graphing. So raise your hand if you use primarily Excel for graphing. If you have a data set, how will you graph it? R? Okay, what about MATLAB? Anything that I missed?
I use SPSS. I'm a psychology student.
SPSS? Okay. That's a good one. Tableau? You're a Tableau guy? Why are you here?
I'm also taught, so I figured out.
Oh, okay, sure. Yeah, this might be a little basic, but it'll be fun. It's exciting. So if you guys have any questions as we're going along, feel free to interrupt me, and we can talk through how you might use this in your own research and your own work. Okay, so as I mentioned, today we'll be talking about business intelligence a little bit, the role of data visualization. Tableau really comes from the business intelligence space. It's used by just a ridiculous number of companies to analyze, customer data sets and things like that. So it's pretty exciting. Okay, so what is business intelligence? Well, basically, it's just data-driven decision-making. And this workflow that I'm going to show is also applicable to research. It's not just in the business field. So business intelligence starts with data. And you try to extract information from that data. And so the way that you do that is ask questions about the data, such as how many or how much or what are. So in the business realm, this might be how many sales are in the Southeast, or how much profit are we making off of this product. In the science realm, it might be how much pollutants are entering the Chattooga River, or any other sort of scientific question. From that information, we try and get knowledge out of it. And this is different in that knowledge asks the why are questions. So why are sales in the Southeast low? Or what are the causes of pollutants in this river? So it's a flow from data to information to knowledge. And then finally, with that knowledge, you can act on it. So how do we increase sales in the Southeast? How do we prevent pollution in this area? What can we do to limit the negative effects of some virus or something? So it's really just this basic flow chart. And data visualization plays a big role in this. It's very powerful at answering the first couple questions. So how many, how much, and then it can start to get into the why are questions if you do it properly. So let's just take an example of how data visualization is important to this sort of process. Okay, so this is raw data. You guys have 30 seconds to count how many sevens are in this data set. Okay, anyone have any idea?
21.
21, 16, 17, okay. Any other guesses? The point is that it takes quite a while when you're dealing with just raw data to figure out these sorts of questions. We asked how many sevens are there, and if you're looking at raw data, that really kind of sucks. One of the things that we can do to make it easier is, what if we were to highlight the sevens? What if we were to turn them blue? Another thing that might be helpful, what if we push all sevens to the top? Right, so we can use these types of visual cues because we are automatically drawn to visual differences in a picture, in a data set, in a place. And the point of a data visualization is to use those sorts of cues to make information more readily available. An even better way to figure out how many sevens are in the data set is to count them and put them in a bar chart. We can do that here. We can see that there are 17 sevens in this data set. There are 34 threes. There are 28 twos. This sort of graph consolidates all of the information contained within that data and makes it very easy to read right away. There's an even better way that we can organize this. If we want to ask, well, is 7 the fifth largest or the seventh largest or whatever, it's kind of hard to get that from this bar chart. But if we simply sort the bar charts from greatest to least, we can clearly see that 7 is the third least numerous number in that data set. So if the question is, if 7s are sales within the Southeast, we can start to work and act on that. Sales within the Southeast are low relative to all these other regions that we're looking at. And that might be an action item and starting to answer those knowledge questions, why are? So we can start to get to that knowledge based on how we develop these graphs. With that said, graphs can be done poorly. So how many people have seen graphs like this? And especially look at the title, a quantitative analysis of the number of occurrences of each digit in the data set. That is absolutely gross, but it shows up all the time in academic research. You try and sound smart, but in doing so, you obfuscate the results that you're looking at. And look at this pie chart. Pie charts are like the worst type of chart you can possibly do. It takes me a second to recognize that the 7 is the light red and that there are 17 of them. And it's very difficult for me to compare that to any of the other colors really quickly. So there is a way to do data visualization poorly, and it's important to keep that in mind. But here's a question. Is this still more helpful than the raw data itself? I'd argue that it probably is. It's not a great visualization, but it does help to distill the underlying information within that data. However, this bar chart that we showed earlier is probably the best way to do it. So there's kind of this progression from raw data to terrible visualizations to a lot more clear visualizations. And there's kind of this spectrum. So there's a few takeaways from this. It's not just making a visualization, it's understanding your audience and what they might be drawn to first in the visualization that you're doing, and what type of story you're trying to tell with that visualization. So that's pretty important to know what your audience is and know how you'll plan to use the graphic and how that graphic will hit the action items that you're looking for. So here's a good historical example. Some people call this the best graph ever. Has anyone seen this graph before? Okay, a few of us. So this graph was put together by Charles Minard. He was a French engineer back in 1869. And let me just take a second to explain what's going on here. This is Napoleon's march from Lithuania to Moscow. And on the left side of the screen, he's starting in Lithuania and he's marching across Eastern Europe. So it turns out that the x-axis and the y-axis of this are latitude and longitude. So he's marching towards Moscow. The width of this line represents the number of troops that Napoleon had. So at each little reduction in the width, there was another battle and he lost troops. Once he gets to Moscow, he's forced to retreat, and that's where the black line starts. So the black line starts and he's retreating all the way back to Lithuania, all the while losing more and more troops. And these vertical lines actually correspond to different temperatures, showing that in a Russian winter, you're losing a lot of troops because they're below 0 temperatures. So it turns out that there's actually 5 dimensions on this chart. There's latitude, longitude, number of troops, whether or not he's advancing or retreating, and finally temperature. So it turns out that you can actually plot this chart on a map of Eastern Europe. That's just to reiterate that it's latitude and longitude. And this sort of chart is very information dense and it tells a lot. So do people like this chart? Do you not like this chart? How do you feel about it? It's been called the best chart ever. Different people. I hate this chart. I think it's terrible. And this is why I think it's terrible. Napoleon lost, end of story. Like, I don't care where he lost troops. The fact is he lost. He lost 98% of his troops. That's the only thing that I care about. So audience and goal of what you're trying to do with the visualization that you're developing is super important. Do you need an executive version that just a one key takeaway from what you're graphing, or do you need the entire information dense thing? That's something to keep in mind as you're graphing and developing graphics and things. Okay, so now I'm going to go into what is Tableau. So Tableau is kind of an industry-leading data visualization software package. This is just like a Google Trends graph, and the blue line is Tableau, and these are a few competitors. So Tableau is really leading this space. Both my brothers work for 2 different random companies, and they're both like using Tableau every day of their lives. So it's getting more and more popular. It's a great software package. It's the only thing that brings me joy in life. So I hope that you also appreciate it.
So I just had a quick question about, I plan on learning how to use R programming a little bit later down the line. Does this software have features that would make it distinct from R that would make me want to invest a lot of time and effort into learning this as well as R?
Yeah, so for online people, the question is, like, what sort of overlap is there between Tableau and R as far as capabilities and things like that? Another part of your question is, how much time should you invest? I will argue that you will learn everything you need to learn about Tableau today.
Oh, okay. So
Yeah.
3 hours. That's all I need to invest. Okay.
Maybe 10 hours to learn like all the details and to really get it for what you're trying to do with it.
Yeah.
So Tableau is strictly data visualization. It doesn't do very much data processing or cleaning. So you might want to still use R to process your data, to do statistical analysis, and then you can bring in those R files directly into Tableau. So if you've heard of like ggplot2 for R,
yeah.
I would use R for everything up to that, and then instead of using ggplot2, use Tableau, because Tableau is a lot easier and better in my opinion.
So it has similar functionality as ggplot, but it's easier to use.
Yeah.
Okay, that's good to know. Thank you.
Yeah. Cool. So let's just switch to Tableau and start playing around with it.